Hello everyone, Mr. Schultz here as we dive into using compositions to verify inverses. So we're going to actually prove that two functions are inverses by using compositions. So basically, we're going to prove it without creating the inverse. We're going to put one inside the other. Wait, what does that mean? Well, remember compositions. If we're going to have f of g, and it looks like this, like f of g, like right here, and then of x, that means, hey, we're going to write this equation out, this f of x first, and we're going to say, hey, 2x, the input, 2 times the input plus 1. And what this means is we're going to, instead of putting like any number, we're going to put this function inside. So now I'm going to put 2 times 4x plus 1. And then I have this plus 1. So if I work my magic here, I should get 4x plus 4, and then I still have this times 2, and I still have this plus 1. So I get 8x plus 8 plus 1. So I get f of g of x is equal to 8x plus 9. I just did all that work just to be like, hey, look, there we go. So we plugged one into the other function. That's it. But how can we use this to prove that two functions are inverses? Well, here's our 20-minute lecture in 10 seconds. If we plug one function into the other one and we end up with x, and we do it the same way, but we plug the other one, like f into g instead of g into f, and we get x both times, well, congratulations, those are inverses. So f of x and g of x are inverses. Inverses. So the inverse of x is equal to g of x. Because that's what we're saying. Hey, look, if this is true, then f of x and g of x are inverses. The end. Well, let's test them out. So determine whether each pair of functions are inverse functions. Right, yes or no? So let's plug one into the other one and do it again. So let me give it a pause. So technically, if it works for one, it should work for both, but I'm going to do it both times. Let's see how fast I can do it. So if I'm going to plug in g of x into here, I'd probably want to multiply this out a little bit. I'd probably say, hey, this is half of x minus 3 halves, and I'll plug that in. So this is equal to 2 times g of x plus 3. So I plug this in, minus 3 halves, and wait a second here. I could have skipped that. 2 times a half is x, and 2 times 3 halves is minus 3, plus 3. Hey, this guy is an inverse. F of g of x is equal to, cross these out, x. Let's try g of x and plug in f of x into g of x. So I know I'm going to have 1 half. I have my input minus 3. Well, my input is going to be 2. Well, let's use a different color on that one. Let's use green. 2x plus 3. So knowing this, I have 3 minus 3. That cancels out. So I get 2x, and then I have half of that. Well, half of 2x is just x. So technically, I could just prove one of these is true, but I want to make sure I do it both times because maybe I made an error. So I'm checking twice. So right here, because of that, and because of that, I can say, yes, they are inverses. All right, well, let's test the other one. I only need to prove one of them doesn't work. So let's put g of x into f of x. So f of g of x is equal to 2 times the input plus 2. So I know I'm going to have 2 times 1 half x plus 2 plus 2. So if I do 2 times this, that actually cancels out and I don't have to do anything else. And I still have this x plus 2. So I have x plus 2 plus 2. And quick, why would somebody get this wrong? What would one reason be? All right, they might confuse us and be like, all right, minus 2 plus 2 and get it done. For some reason, I might confuse it and be like, hey, look, there's a 2, the 2's match, so they cancel out for some reason. But 2 plus 2 ain't 0. So this is x plus 4. So I say, no, they are not inverses. So f of g of x is equal to that. So that doesn't work. All right, guys. Thanks for being with me, and I'll catch you in class. Bye.